X squared over 4 minus y squared over 1 equals 1. You know this is a hyperbola because, and both variables are being squared.
Yeah.
Good. Is it going to be horizontal or vertical? Horizontal because x squared comes first. Notice we do not have an h and a k, so our h and k will both be 0, so that cuts out a couple letters here. Oh, I forgot to mention, if you'll notice, the c squared formula changes. For a hyperbola, it's a squared plus b squared. Sorry about that. So we need 3 letters here. We need an a, a b, and a c. For a hyperbola, a is always the first denominator there, or a squared, I should say. So if a squared equals 4, what does a equal? 2. And if b squared equals 1, what does b equal? 1. And if c squared is a squared plus b squared, what does c equal? Square root of 5. All right. The a and the b is how we get the magical invisible box. So from the center, HK, 0, 0, we're going to go left and right 2 units. I'm going to make these close because these are actually part of the hyperbola. These are your vertices. Your co-vertices will be up and down 1. Going to make it open because it's not really part of the graph. Sorry, this is so small. Once you get your A, your B, make a box. The diagonals of your box form asymptotes. Whee! These asymptotes have equations. Notice the y-intercept for all the asymptotes in this picture is 0. So instead of y equals mx plus b, we're just dealing with something of the form y equals mx. Slope is rise over run. So how far up for this asymptote here? How far up did we have to go? And how far over did we have to go? 2. So what is its equation? Y equals. There you go. And how about the other one? Yeah. Good. Awesome. Finish this off by sketching in your hyperbola. So starting in your vertex and go towards your asymptotes. And lastly, we just need to fill in the foci. Radical 5 is a little more over 2. I don't know if I'm going to fit it in there. Let's see what I can do. So radical 2, 2 point something here. And 2 point something here in this direction. Oh my gosh. That's okay. Hooray! Fun fact, for every ellipse there's an associated hyperbola. If instead of that minus there we put a plus, then what would happen is your graph of your ellipse would be in this little box here. Oh, who's cute? Who's adorable? You are. Now the foci would not be the same. but the A and the B are all right there.